All right, let's dive into some seriously cool tech today. We're going to take a look at a complete all-in-one environmental monitor. We'll break down exactly how it works, what makes it so incredibly tough, and how it's already changing the game for industries from farming all the way to renewable energy.
So, everything really starts with a huge challenge. Think about it. If you're trying to run a farm, or a wind turbine, or even a busy shipping port, you absolutely need accurate, real-time data. But how do you actually get that information reliably from some remote, harsh place where you know traditional equipment is just going to freeze up or break down? Well, the answer looks a little something like this. These super compact stations can be put just about anywhere you can imagine, from a sun-scorched field to a freezing, windswept industrial site. They are literally the front line of data collection, constantly grabbing environmental intelligence and beaming it right where it needs to go. Okay, so what's the secret sauce here? What makes this system so different? Well, at its core, it's an all-in-one design that's built around one really clever innovation, and that gives it a massive leg up on the old way of doing things.
And that key innovation is the ultrasonic sensor. So instead of those traditional spending cups and weather vanes you're used to seeing, this device uses sound waves to measure things like wind speed and direction. Now, here's the kicker. That means there are zero moving parts, nothing to wear down, nothing to freeze up solid, nothing to break off in a storm. For reliability, that is a total game changer.
And there's another huge benefit. When you get rid of those rotating parts, you also get rid of something called inertial effects. That's basically the tiny bit of lag that mechanical parts have when they're trying to speed up or slow down. Without that lag, you get faster, more accurate measurements every single time. The whole system is also incredibly modular. You could start with just a basic unit that only monitors the wind, or you can go all out and build it into a complete environmental station, even with its own solar panel. It's really all about setting up the device for exactly what you need, no more, no less. So, what can it measure? Pretty much everything. You've got your wind, temperature, humidity, the basics, but then you add atmospheric pressure, rainfall, solar radiation, and even air quality particles like PM 2.5. You can even hook up sensors for things like soil moisture, which is huge for agriculture. All told, the system can combine up to 10 different measurements into one single compact unit. It's wild. So we know what it measures, which is a lot. But how does that data actually travel from a remote field all the way to your phone screen? Let's follow the data's journey. This diagram here just lays it all out perfectly. Over on the left, you've got the sensors doing their thing out in the wild. They collect all the data, and then it all begins this seamless wireless journey that ends up literally on the devices we use every single day. It's a smooth flow of information, right from the environment to your screen. Let's break that down. So, step one. The sensors grab the raw data. Then, and this is clever, they use a long-range, low-power system called LoRa to send that info to a central data collector. From there, a 4G gateway just pushes it all up to the internet. And the final step? Well, that's you. You log in on your phone or your laptop and see everything as it's happening. Simple. And the really crucial thing to understand here is the flexibility. This system isn't locked into just one way of talking. It supports a whole bunch of different protocols, from 4G and LoRa to Wi-Fi and other industry standards. What that means for you is that it can plug into almost any existing setup you can possibly think of. Now, a fancy system like this is only as good as its ability to take a beating from the elements, right? So let's look at the actual proof that these monitors are built to last no matter what you throw at them. First up, the cold. For places that get serious ice and snow, there's an optional heater. And here you can see it being tested at a bone-chilling -40 degrees Celsius. That tiny heater keeps the probe from icing over, making sure you're getting accurate data even in the absolute worst winter weather. Okay, what about salty coastal air? Well, this is a salt spray test. They basically blasted this device with corrosive salt spray for 168 hours straight, for a whole week. And the result? It just kept on working. No rust, communicating perfectly. That makes it ideal for ports and marine environments. But look, durability isn't just about surviving. It's also about staying accurate. Every single one of these units goes through intense high and low temperature calibration. This makes sure that whether it's a scorching hot day or a freezing cold night, the numbers you're seeing are always on the money. And finally, it gets this official rating, IP65. So what on earth does that mean? Well, the 6 means it's totally sealed against dust, and the 5 means it can handle getting hit with jets of water from any direction. So yeah, dust storms, heavy rain, bring it on.
Okay, so we've got a tough, accurate, all-in-one sensor. That's great. But now let's see how that actually translates into the real world. Where are people using this? And how do they get all that valuable data?
This is really where it all comes together. Think about smart agriculture. If you're monitoring soil moisture and rainfall, you can optimize irrigation and save a ton of water. Or for port authorities, getting real-time wind data is absolutely critical for keeping ships safe. For renewable energy, tracking solar and wind helps you squeeze every last watt of power out of your systems. And of course, for environmental protection, monitoring air quality helps us keep tabs on pollution.
And honestly, the best part might be that all this incredibly detailed, critical data gets delivered right to the palm of your hand. It's all there through simple, clear dashboards on your computer, your tablet, or your phone, turning all these complex measurements into insights you can actually use.
So this all brings us to one final thought. This kind of technology gives us a live data feed from pretty much any environment on planet Earth. That's a new level of understanding, a new level of control. So the real question is, with this kind of power at our fingertips, what problems are we going to solve next?